Hi, and welcome back to my channel. This week's problem is a really interesting one, I think, and it's about finding the area of this blue circle. Now, as you can see, we've got a triangle that goes through a right angle triangle that goes through the center of that circle and has line segments at the top left of that triangle extending outside of the circle of length 8 and at the bottom right of length 3. Can you solve this problem and work out what the area of this circle is? Now, if you want to have a go at this problem yourself, I've labeled the vertices, the important vertices, and the important points of intersection on that diagram for you. If you want to have a go at this problem yourself, pause the video now. Otherwise, I'm going to show you my solution in 3, 2, 1. Okay, so the first thing that I wanted to do is I wanted to put on some radii, and I wanted to make these right-angled triangles. Now, the reason for that will become apparent very shortly. Obviously, they're going to have a length r, which is the radius of the circle. I've labeled the other radii on there as well. Now, these two angles will be the same. Okay, and you could do that with algebra. So I could label that green angle theta, and then this bottom right one of that larger right angle triangle is going to be 90 minus theta, and then take away the 90 from inside the square, you would get theta again. Now, by the same token, these two angles, bottom right of both of those smaller right angle triangles, are going to be the same as well. Now, what that means is that we have got similar triangles because they've got all the same angles inside of them, and so there must be similar triangles. Now, if we had a look at those triangles, we've got a length of r plus 3 and r plus 8 on the hypotenuse. And what we can do is we can look at the scale factor between those two triangles. So to get from r plus 3 to r plus 8, we would need to times by r plus 8 over r plus 3. And we want to go from the bigger one to the smaller one, so we need to divide by that fraction. And actually, when you divide by a fraction, it's the same as timesing by the reciprocal. So times by r plus 3 over r plus 8. And that will give us r brackets r plus 3 over r plus 8. Now, if we take that back to the diagram, we can see we've got it labeled there on the bottom right, smallest right-angled triangle. Now, I'm now going to use something called the intersecting chord theorem to make an equation. And that is essentially if you've got a length, a line segment, a length of that line segment that goes from the circumference of the circle to a point of intersection times by the point that starts on the circumference of the circle again to the point of intersection, that will be equal to point on the circumference of the circle to the point of intersection times by point on the circumference of the circle to the point of intersection. Now, that might sound a little bit complicated when I've explained it there, but actually what that means is we get this equation here. So 3 times by 2r plus 3 is equal to this fraction times by itself squared. Okay, now from here, we've got an equation with just r in, so we need to do some rearranging and then we can solve this equation, although it might turn out a little bit complicated and have some larger powers than we might like, but let's find out. So I am going to, first of all, expand the bracket on the right-hand side, and I'm then going to square the fraction on the left-hand side here and get this. I'm then going to multiply up by the denominator, and then this is where it's going to get quite complicated, as you can imagine, and we're going to get this. We've got loads of terms here. We need to simplify them. So let's do that. And then we're going to get everything onto one side, well, the left-hand side of this equation, because we've got r to the power of 4 on the left-hand side. So that's going to give us this. And then what we're going to do is we're not going to use the quartic formula because that is massive. We are going to use a calculator or other online software to solve that, although there is a formula like the quadratic formula. That gives us an answer of r equals 12. Now, that is the only possible solution. When you do this, it gives you 4 solutions, 2 of which are imaginary. If you don't know what that is, don't worry about it. And another one is a negative value. Now, obviously, the radius can't be negative. So the only solution we get, the only possible one, is r equals 12. And then obviously, once you've got that the radius is 12, to get the area of the circle, we just need to do pi r squared. So pi times 12 squared gives an answer of 144 pi units squared, whatever those units are. So I hope that if you attempted this problem yourself, you were able to get the same answer. If you had a different solution, please share it down in the comments below, because I always enjoy reading those, and I'm sure other people do as well, to see if they've got the same solution and if their method is there as well. And if they've got any problems with their method, hopefully they can check your one out, your solution. All that's left to say from me is thank you very much for watching. If you liked this video, please drop a like on the video. And if you're not already, please consider subscribing to the channel. Thank you so much for watching. I will see you next Monday at 5 p.m. for another problem solving video. Until then, bye-bye.